Hello! In this lesson, we will consider the most important concepts of VideoCAD software. These are camera view area and horizontal projection of the view area. View area. This is a three-dimensional geometrical pyramid-shaped figure with a vertex starting from the camera lens. View area is in the shape of a regular pyramid only if the lens focal length is more than 3 to 4 millimeters. In case of a short focus lens, the actual shape of the view area is different from the pyramid because of the influence of lens distortion. Any object inside the view area will be visible on the screen when it is not shaded by other objects. Objects outside the view area will not be visible. An object that gets partially into the view area will be partially visible. View area can be infinite. View area may be limited by the ground or by other obstacles. Look at limiting the view area near walls with a door and window openings. The view area minus shading from environment obstacles, these are uncontrolled zones, is called in VideoCAD the control area. It is important to understand that the view area and control area are complex three-dimensional shapes. They can be fully represented only in 3 dimensions. But designing and making documentation is more convenient in 2D projection. The transition to 2-dimensional is possible only when the camera observes objects on the ground or other horizontal plane. However, this condition is satisfied in most real tasks of video surveillance. To work in 2D VideoCAD with constructs of horizontal projections of the view areas, let's consider the principles of construction of these projections. To construct the projection, it is necessary to specify a range of heights that must be controlled by the camera. For example, to monitor people who do not try to hide from surveillance, it is sufficient to set the range of heights from 1 to 2 meters. In this case, faces of people with a height from 1.2 to 2 meters get into the range of heights of 1 to 2 meters. Here, we can see that the near bound of the view area projection limits visibility of an object of minimum height. The far bound of the projection limits visibility of an object of maximum height. Hide vertical projection and move to the horizontal projection. Let's place 3D models of the maximum height of 2 meters on the bounds of the horizontal projection of the view area. Then we will watch on the screen how the model will look. Now, place on the near bound of the projection 3D models of people of 1.2 meters. This is the minimum height. We can see our view area in 3D with our three-dimensional objects. We see that the face of a person of minimum height is seen on the screen when the person is farther than the near bound of projection within the projection. The face of the person is not seen on the screen when the person is closer to the near bound of view area projection. Thus, The near bound of projection limits visibility of faces of people of minimum height. The side bounds of projection limit the visibility of faces of people of maximum height. If an object is outside the projection, his face gets out of the view area and thus disappears from the screen. The far bound of view area projection limits visibility of faces of people of maximum height as well. So, if a tall model is farther than the far bound, its head does not get entirely on the screen. Thus, we see the important principle of constructing horizontal projection of the view area in VideoCAD. Any point located within the horizontal projection of view area on the plane and within the predetermined height range vertically will get into the view area. Here, the view area implies a three-dimensional object. If this point is not shadowed, it will be visible on the screen. We have considered only one of 8 possible positions of the camera. Let's check constructing the view area projection in a different position when camera height is less than the maximum height of surveillance. In this position, the view area becomes infinite. Set the camera height less than the maximum height of surveillance. Then, in the same way, move the 3D model along the near border of the view area projection, watching visibility of the head of the model on the monitor. We see that in this camera position, near the border, limits the visibility of a tall model. For the rest, the principle is valid. Actually, the principle of construction of the view area horizontal projection is valid in all camera positions. Enable modeling lens distortion. Rotate the camera around its axis. The shape of the view area and its projection becomes more complicated. Move the 3D model of minimum height along the border of the projection, watching the visibility of the head of the model on the monitor. If the model is within the projection, the head of the model is visible on the monitor. The head of the model outside the projection disappears from the monitor. So, the principle of construction of view area horizontal projection is valid in modeling lens distortion and camera rotation around its axis. Let's disable modeling lens distortion and camera rotation around its axis. Place in the view area a shading object. We can see how it looks in 3D. We will use a two-dimensional projection and the image on the monitor. Move the 3D model along the border of the shadow, watching visibility of the head of the model on the monitor. We see that if the model is within the horizontal projection of the control area, then its head is visible. If the model gets into the shading, then its head disappears from the screen. The principle of construction of control area horizontal projection is valid in modeling shading. In any case, VideoCAD constructs horizontal projection of view area and control area so that if an object is within the projection on a plane and within a predetermined height range, then it gets into the view area. In other words, if an object is located on the projection, then it will be visible. This is a very important principle of constructing projections, which allows for using the horizontal projections in designing. The basis of design in VideoCAD is working with the horizontal projections of view areas on layout. The layout might be supplemented by graphics background and additional constructions. For this purpose, VideoCAD offers many useful tools. The layout might be supplemented by 3D models from the VideoCAD library. If necessary, we can import additional 3D models from the open Google 3D warehouse. We can move the camera and rotate it on all planes. We can change lens focal length and view angles by moving grips on the projection. We can change camera parameters and position. For example, height, angle of rotation around its axis, and other parameters. Look at a 3D model of an image from the camera. We can see the full 3D representation of the view area. It is particularly important in cases where 2D projection is not enough. In three-dimensional view, we can consider every detail. We can look inside the view area, consider its intersection with furniture, models, etc. See what resolution it intersects. Finally, let's consider an example of a complex view area constructed with taking into account the lens distortion. We see the distribution of the spatial resolution, shading, rotation of the camera around its axis. We can also look inside the view area. Look out from the view area. So, this lesson is over. Thank you for your attention.